Howdy folks. In this video, what we're going to do is we are going to begin discussing factor markets. Now what I want to do to talk about factor markets is I want to remind you that there's two basic kinds of markets in microeconomics. We have factor markets and then the other one is product markets. And one of the best ways, in my opinion, to understand the relationship between factor markets and product markets, or how they're similar or how they're different, is to review the circular flow diagram. Recall in the circular flow diagram that we have households over here, which are consumers basically, or individuals. Consumers. And then over here on the other side we have firms, which are basically businesses, right? Businesses. Okay, and what we have done up to this point with the conversation that we have had in terms of markets between firms and households has mostly been regarding product markets. What we said previously is that firms, they produce products, right? Firms produce products, and then consumers, they buy those products. Now, why do consumers buy products? Because they want utility. They want satisfaction. They want to consume things and have good feelings up in their brain. Okay, and so they want to eat food, and they want to watch TV, and they want to sit on comfortable furniture, and they want to drive vehicles. Okay, and they want to drive the vehicles for fun, or drive the vehicles to go to the store, or drive the vehicles to go to work. But consumers, they want usefulness or satisfaction or happiness, and that is utility. Now, remember, why are firms producing products? Why are they selling products to consumers? Well, because they want profit. Now, that profit ultimately turns into income for the owners of that business, and the owners of that business are actually consumers, and then they use that profit to be able to buy products from other companies and have utility. So everything in the very end, regardless of profit or whatnot, everything boils down to utility in this model and in microeconomics. So consumers, they give their money, they send their money over to businesses and to be able to buy the products in a market. And that's why we wind up with a supply and a demand curve for product markets. We have product supply and we have product demand. And over here, consumers in the product market, they are demanders generally, and firms are suppliers. Suppliers. Okay? And this is what we have talked about up to this point. We've talked about product markets and elasticity of supply and demand in product markets, the determinants of supply and demand in product markets. And what we're now going to do is we're going to now talk about factor markets. So we're going to move to the top side here of the circular flow diagram, and we're now going to say, well, where do firms get all of the resources to make their products? They don't conjure these products out of thin air. You know, they don't have a magic wand and just wave it and then all of a sudden there's a car or a bunch of cars or there's some food or whatnot. Firms have to produce. They have to take resources and then change them, turn them into something else, a final product, and then sell it to the consumers. So where do they get all the resources? Well, remember, we said that the resources that firms use are called factors of production. Factors of production. Well, and our main categories are land, which is natural resources, labor, which is the effort and time of people, and capital. And capital is anything that labor and land. Anything that labor makes out of land is capital. And so capital can include things that go into the product and are then sold. Capital can also be machines that are just used to make the product. So where do firms get the land, labor, and capital? Well, they get it from a lot of different places, but they purchase these things usually in markets, just like product markets. But instead of buying products, they're buying factors of production. And therefore, we call those markets where the firms get their resources, we call them factor markets. Now, if you go back several lessons, I explained at the beginning of this unit that firms get land and capital from markets that are very, very similar to product markets. Because of the value chain. There's a company that makes something that this company wants to use so they can make the final product and then sell it to consumers. So if you go back to my modified circular flow diagram and to the value chain, you'll remember that businesses typically get their factors of production of land and capital from what look like product markets. So what we're mostly going to talk about in this lesson and in the next lesson is the factor of labor. And where does labor come from? Labor comes from households. Those the very same people that are buying the products from the businesses are also working for the businesses. And so households are providing the labor. We're going to say labor market, which is one of the factor markets. And so households provide labor to the labor market, and firms purchase or rent. They borrow. They pay some money to the consumers to use them for a little while so that they can produce their stuff that is then sold back to people. And then firms obviously pay. They have to send money to pay the households to rent the labor, all right? And so here's the interesting thing, is that now the tables have turned. Firms in the labor market are no longer suppliers, they are demanders in the labor market, and households are not demanders anymore in the labor market, households are suppliers. And so everything we're going to do now, we're going to talk again over the next couple lessons about, for example, we're going to talk about elasticity of the demand for labor. We're going to talk about the determinants of the demand for labor, the determinants of the supply of labor. And so all the stuff that we've already talked about that reflects product markets, many of those things we are now going to talk about with respect to the labor market. And the first one that I want to talk about is this. It's a concept called derived demand. Derived demand. The idea of derived demand is this. The word derived basically means like coming from something else. Okay? And the demand, since firms are demanders in the labor market, the demand for labor is a derived demand. So demand for labor is derived. And what is it derived from? Well, it's derived from the demand for products. And here's what I mean by that. Firms are suppliers of products which are then sold to consumers who are the demanders of those products. Why? Because the consumers want utility. They want to maximize their utility. The more of this product that the consumers want, the more that they demand. The higher the demand for this product, the more workers that the firms are going to need to make that product. And so, the higher the demand for the product, the higher the demand for the labor that makes that product. The lower the demand for the product, the lower the demand for the labor that makes that product. And that's what derived demand means. So you have to, throughout in the back of your mind, as we talk about the labor market, remember that we only need a carpenter, we only need a cabinet maker if we're going to make cabinets. But if people don't want cabinets anymore, We don't need cabinet makers. There was a movie I saw recently. This will probably age the video here. So recently I saw the movie Mary Poppins Returns. So if you've ever seen the movie Mary Poppins from the 60s, this is Mary Poppins Returns. And you know, it takes place in the early 1900s or late 1800s or something like that. It's in London, right? Well, all of London is lit. The streets are lit by gas lamps. And so one of the main characters in the movie, he rides around on a bicycle, and at night he lights the lamps and turns on the lamps so that they're lit. And then you know, in the morning he rides around and he turns off all the lamps. So I'm sure that was a very important job. I mean, I don't know how historically accurate it is, but I assume if it is historically accurate, then there must have been a job at one time where people would ride around and light the lamps and turn the lamps off, these gas lamps. Well, now roads are lit by electrical lights, and so there's no need for these lights on the road, and therefore there is no need for the lamp lighters. And so the demand for lamp lighters is going to be derived from the demand for having gas lamps on the road. And since there's no more demand, really, or at least not in America, to have gas lamps on lighting the roads or lighting the sidewalks, then there's no demand for a lamp lighter. And so it's important for you to understand that the more that a product is in demand by consumers, then the more there will be a demand for the labor that produces that product. Okay? All right. We're going to move on now to a couple new concepts in microeconomics that are specific to factor markets. So before I explain these new concepts to you, I need to bend your brain just a little bit. Okay, so I need to soften up your brain. I need to start someplace where you already understand, and I need to bring you to a new understanding. This is going to be fine for you if you're pretty strong in mathematics, but if you struggle with math a little bit, especially if you struggle with functions, then this could be a little challenging. But I think when I go through this little exercise, it's going to make sense to you. So I just need to bend your brain a little bit. You've seen one of these before. You've seen several of these in my class. You know, basically this is a very simple situation where we have a firm with a bunch of different possibilities for production quantities. If this firm produces 0 units, they will earn 0 revenue, but they will still have to pay out 100 in costs. Why do they still have to pay out 100 in costs? Well, those are their fixed costs. Remember, a company still has to pay its fixed costs even if it doesn't produce anything, even if it doesn't sell anything. So this company obviously has $100 in fixed costs because at a quantity of 0 with 0 revenues, they still have to pay out 100 in fixed costs. Okay, so now these are the situations as quantity goes up. If this company were to produce 1 unit, they would earn $50 in revenue. If this is dollars, they would earn 50 in revenue, but they'd have to pay out 120 in costs. And so on, all the way up to 10 units where they would earn $410 in revenue and they'd have to pay out $345 in costs. So mathematically, when we have been doing this, we have been this is mostly related to a product market, not a labor market. And the reason that this is mostly related to a product market is because this quantity is a quantity of a product. It is not a quantity of a factor of production. And so the independent variable in this, the independent variable here is a quantity of a product, and the dependent variables over here reflect what would happen if the independent variable were a particular number. So if 4, then 188 and 186. If 7, then 308 and 261. And that's the idea in math of an independent variable and a dependent variable. So typically what we do mathematically is we count up in ones by the independent variable, and then we ask, if the independent variable was this number, what would the dependent variables be? And that's just a mathematical concept. And everything that we've done up till now, quantity has been the independent variable. Now, I'm going to put another dependent variable up on the board, okay? This is a dependent variable, and it's called workers. Workers. And here's what this dependent variable is saying. If this company produces a certain number of quantity, or if they want to produce a certain quantity, how many workers will they need to produce that quantity? Let's say to produce a quantity of 0, they need 0 workers, which makes sense, right? If you're not going to produce anything, you don't need any workers to produce nothing. But now, if they want to produce 1 unit, let's say that to produce 1 unit, they need 1 worker. 1 worker can produce that 1 unit for them. So they hire 1 person. That person would produce 1 unit. The revenue they would earn would be 50, and then their total cost would be 120. In fact, the cost went up by $20 here. It could be that it went up by $20 because of the, I don't know, maybe the $8 that they had to pay the 1 worker. So part of this cost over here is going to be what they had to pay this worker. Let's say to produce 2 units, they still only need 1 worker, because 1 worker can produce more than 1 unit in this particular situation for whatever this product is. Now, let's say that they want to produce 3 units. Again, that 1 worker can produce 3 units for them. Let's say they want to produce 4 units. Again, that 1 worker can produce 4 units. But now, when they get to the point where they want to produce 5 units to sell so that they can earn $230 in revenue, that 1 worker is not able to produce the 5th unit. That 1 worker can produce the first 4 units, but in order to produce that 5th unit, this firm is going to need to hire a 2nd worker. And now it's going to take 2 workers to produce 5 units. Similarly, it'll take 2 workers to produce 6 units and 2 workers to produce 7 units. But now let's say if they want to produce 8 units, that it's actually going to take 3 workers to produce 8 units. And it'll also take 3 workers to produce 9 units, and it'll also take the same 3 workers in order to produce 10 units. And so if you were to ask the question, well, how many workers would I need? That's a dependent variable. How many workers would I need to produce 6 units? The answer would be 2. How many workers would I need to produce 8 units? The answer is 3. So this is the independent variable, and this is the dependent variable. All right, so now I'm going to do something magical. I am going to magically change this graph. This is an independent variable. These are dependent variables, and this is also a dependent variable. I am going to magically transform this variable into an independent variable, and I'm going to simultaneously magically transform this variable into a dependent variable. And I'm going to show you how I'm going to do that. So when I do this, instead of saying, if quantity is this, then what would these other things be? Now we're going to say, if we had 0 workers, then how much quantity would we have? Then how much revenue would we have? Then what would our total cost be? And this is how I do it. What I basically do is I go to the highest, well, really lowest here, I guess, the highest quantity on each one of these. So the highest quantity for 1 is 4, and then I erase all the rest of them. So I'm going to erase these, erase these, erase these, and there we go. Now I go to the highest quantity for the 2nd worker, which is 7, and I'll erase everything else. Erase these two lines, and then I'll do the same thing for the 3, okay? I'm going to go to the highest quantity for 3 workers and erase the other 2 lines. And now what I have done is I have now changed the relationship of the table into making the workers the independent variable and making quantity, total revenue, and total cost all dependent variables. And now with this table, this is the question I can ask. If I employed 2 workers, how much quantity could I produce? And the table says if you employ 2 workers, you can produce a quantity of 7. Okay? If I employ 2 workers, how much revenue will I earn? Well, if you employ 2 workers, you'll earn $308 in revenue. Okay? If I employ 2 workers, how much cost will I incur by producing 7 units? And the answer would be you would incur $261 in costs. And so it's important that you understand that what we're going to start working with right now when talking about factor markets is we are not working with a table where quantity is independent. We're going to work with a table where workers are independent and quantity is dependent. And I think that's going to make sense in what we're going to do in just a couple minutes. All right, so what I'm going to do now is I'm going to explain 3 new concepts to you. And they're very easy to understand, and we can do it, but these concepts are only relevant when our independent variable is a factor of production. Now, I put workers here because we're focusing on the labor market, but I want you to understand that this does not have to be workers. It can also be a factor, it can be land, it can be capital, it can be a specific kind of land or capital. You could put iron ore up here. You could put crude oil up here as natural resources. You could put pine trees here. You could also put capital here. You could put drills or saws or trucks or robots. So what I'm about to explain to you is not unique to only workers. You can put any factor of production. But the reason I'm using workers is because it's a very popular one to use, and also because we're mostly going to be talking about the labor market. Now, the 3 concepts that I'm going to try to explain to you are called marginal physical product, marginal revenue product, and marginal factor cost. And I've made columns for them over here. Marginal physical product, marginal revenue product, and marginal factor cost. Now, I do want to say this, that marginal physical product is often simply referred to as marginal product. So if somebody says marginal product, they're talking about this concept of marginal physical product. Okay? So let me just show you very quickly how we would calculate these things, given the information we have over here and what they mean. Each one of them is a marginal. Do you recall that the word marginal means whenever you add one more, right? If I were to add one, when we learned marginal revenue and marginal cost, what we said is if we were to produce one more item, how much would our revenue go up by? Or how much would our revenue change by? And then we said if we produced one more unit, how much would our costs change by? And then that's how we determined the marginal revenue and the marginal cost. Well, it's very similar. In each one of these cases, we're going to have a change in physical product, or a change in revenue, or a change in a change in cost, because there was a change in the number of factors that we are producing. And so marginal physical product, very simply, this is a really easy one, is the change in quantity produced when you add one more factor of production. And when I say add, I mean employ one more factor of production. But employ doesn't have to be a worker. You can employ a new machine. Okay, I know it sounds like a weird word, but the word employ, as referring to labor, actually comes from the idea of employing something, as in getting it and using it. Okay, so marginal physical product is very simply, it's the change in quantity that your company produces when you add one more factor of production. So if you buy one more drill, can you produce more? Like, let's say you have one drill press and 17 employees all have to use the same drill press, and they have to walk over from their workstation to use the drill press, I don't know, maybe 8 times per hour, and then go back to their workstation. Well, if you bought one more drill press, would that increase production? And if it would, then that would, however much it increased production by, that would be the marginal physical product. So over here, we're counting up by workers. And the question is, when we go from 0 workers to 1 worker, how much did quantity produced go up by? Well, at 0 workers, we produce 0. And at 1 worker, we can produce 23 units. So marginal physical product is going up by 23. And so over here, under marginal physical product, I'm going to put 23. What is the marginal physical product, or the marginal product of the second worker? Well, on the second worker, quantity is going up by 27. It's going from 23 up to 50. And the way you're going to calculate the marginal product is by taking the new number, and subtracting away the old number. And 50 minus 23, that's 27. The marginal product of the third worker is 75 minus 50, which is 25. And the marginal product of the fourth worker is 95 minus 75, which is 20. All right, now let's talk about the marginal revenue product. It's the same exact concept. It is the change in total revenue, the change in total revenue when you add or employ one more factor of production. Factor of production. Okay? So, how much is total revenue changing when you add one more factor of production? Well, at 0 workers, your total revenue is 0, and then when you add 1 worker, your total revenue goes up by 391. So the marginal revenue product of the first worker is 391. What's the marginal revenue product of the second worker? Well, when you add a second worker, your total revenue goes from 391 up to 800. So 800 minus 391, that's 409. So we're going to put 409 here. What's the marginal revenue product of the third worker? Total revenue went up to 1125 from 800. So marginal revenue product is going to be 325. This minus this, 325. And then lastly, on the fourth worker, when you add the fourth worker, your total revenue goes from 1330, or goes up to 1330 from 1125. So if we do this number minus this number, we get, 205. So the marginal revenue product of the fourth worker is 205. By employing a fourth worker, you are earning $205 more. Okay? Now let's look at marginal factor cost. This is another really easy one. Again, it's instead of the change in total revenue, it's the change in total cost. The change in total cost when your company, when a firm, when you add or employ one more factor of production. Factor of production. Okay. So, when you employ one more worker, or one more drill, or one more truck, or one more robot, okay, how much will your total costs change by? Usually it'll go up because costs, you're adding another, you're buying a factor of production or renting a factor of production, so your costs are going to go up. So here with 0 workers, our total cost is 200, but when we employ 1 worker, our total cost goes up to 500. So 500 minus 200, that's 300. What is the marginal factor cost of the second worker? Well, our total cost goes from 500 up to 800. 800 minus 500 is 300 again. What is the marginal factor cost of the third worker? Well, total cost goes from 800 up to 1100. That's 300 again. 300. And then lastly, what is the marginal factor cost of the fourth worker? On the fourth worker, total cost goes from 1100 up to 1400. So 1400 minus 1100, that's 300 again. And you might ask yourself, oh man, looks like marginal factor cost is staying the same. Well, that makes sense when you're dealing with workers because you're probably going to pay all of the workers the same. Well, in this case, in this particular example, each worker is getting paid the same wage. Now, marginal factor cost will not always be the same. It's just the same in this example. Okay? And now that you understand these concepts, we can talk a little more in-depthly about these concepts and what they mean. All right, so what I want to do now is I want to answer a few questions. I want to ask and answer a few questions that are related to marginal product, marginal revenue product, and marginal factor cost. And the reason that I want to ask these questions and answer them is to kind of give you an understanding of what happens in a business practically when they are considering hiring more workers, or why would they hire more workers, or why wouldn't they hire more workers. Now I want you to notice something here in this example that obviously when they hire their first worker, the first worker is going to produce 23, and then the marginal physical product is going to be 23. But when they hire the second worker, something interesting happens here. Marginal physical product goes up, which means each worker is now producing more on average, okay? So if you see the total they're producing is 50. So the average amount that they're each producing is 25. So the question is, why might marginal physical product increase at times? What you're going to see, and we're going to answer this question next, is why does marginal physical product tend to decrease? But sometimes it goes up. And that's a little curious, and I'm curious to know, is it that the second worker is just better than the first worker? Well, we're going to say no, because in this case, we're sort of assuming that all the workers have the same capability. So the question is, why did the first worker wind up going from a production of 23 up to a production of 25 when the second worker came along? And there's probably several explanations, but I thought I'd give you at least one or two. Some of my students in the past have said, well, maybe because the second worker is there, they both start talking to each other, and they're talking while they're working, so maybe he feels or she feels a little more motivated. That could be the case, but I want to focus on economic and sort of physical explanations and capital-related explanations for why marginal physical product might increase sometimes. One possibility here is it could be that this one person is doing a job that is more efficiently done when you have two people. And so, for example, let's say that the person is assembling something at a table, or they're working on a piece of machinery at a table. And it could be that they have to do something to one side of the machine, then they have to move to the other side of the machine and do something, then move back to this side of the machine and do something. And if they have to go back and forth from both sides of the machine regularly, that's going to take some time. And then they finish it and they move on to the next one and they do the same thing back and forth. When they hire this second worker, one of the workers could work on this side of the machine, the other worker could work on that side of the machine, and they can both be working on the machine, whatever the thing is they're selling or producing at the same time, and there's no time wasted as you're going around the table, okay? And so now they're actually able to produce faster, okay? So that is one reason or a couple reasons why marginal physical product may increase sometimes. All right, so now let's ask the question here. So sure, marginal product went up here, but then it goes down to 25 and then down to 20. And we can almost expect that it's going to keep going down. So the question then is, why does marginal product tend to decrease? Well, usually the reason that marginal product tends to decrease is because of limitations on factor capacity. And it's usually related to capital capacity. All right. So here's the situation. Let's say that a company has their employees work at computers, and they have a room that has 8 computers in it. If they hire one worker, that one worker is going to go in and sit down at one of the computers and work an entire shift. They can have more productivity if they hire more workers and use all 8 computers. But what would happen then if they hired a 9th employee? The 9th employee would then have to share computers with the other 8 people. Maybe they would wait until the first person goes on a lunch break, and then they'll sit at that computer while that person's on a lunch break and work for about maybe half an hour, 45 minutes. Then when that person comes back from the lunch break, they would have to get off the computer so the first person can sit down again, and maybe the next person goes on a lunch break and they'd have to sit down. Basically what you have is you have workers sharing capital, okay? And so workers sharing capital. And when workers start sharing capital, they get in each other's way, basically. They have to wait for one another to be done. You know, I gave the example before of if you have like 17 employees, but you only have one drill press. First of all, the employees would have to walk away from their workstation to go use the drill press. But what happens when they get over to the drill press and there's already 2 other employees there using the drill press? Well, they're going to have to stand there and wait until those 2 employees are done using the drill press. Then the employee can use the drill press. So when a company has limitations on their capital capacity, when they're already operating at high capacity for their capital, workers start sharing the capital, and that's going to decrease the added output, the added product output, and that's why we would eventually see a decrease in marginal physical product. Also, generally speaking, you know, the law of diminishing marginal benefit, it says that if something is a benefit to you, if you keep doing it, then eventually the benefit that you receive back is going to get smaller and smaller and smaller and smaller. Well, marginal product is a benefit, and it's a marginal benefit. And so if you keep doing the same thing, keep adding more and more workers, eventually the benefit of adding more and more workers is going to get smaller and smaller and smaller and smaller and smaller because of the law of diminishing marginal benefit. But I thought you'd like to see some of the reasons within a company why capital capacity, or why marginal product would decrease. I had a business a long time ago. It was a massage therapy clinic, and we had 12 massage tables in our clinic. So at any one time, I could only have 12 massage therapists working on 12 clients. If I had 15 massage therapists scheduled at that time, then 3 of them wouldn't have anything to do. They can't do a massage on a table where another massage therapist is already working on a client. And so that's a limitation on capital. If I wanted to change my structure of marginal product, I would need to then get more tables, get more rooms, and then that would revamp this whole system, and then I could see some good stuff with the marginal product, but eventually it would start diminishing again. All right, last one we're going to talk about right now is why does marginal revenue product tend to decrease? Now you can see here that marginal revenue product increases first, but then it decreases, and it's going to continue decreasing here. Well, marginal revenue product is very similar to marginal revenue. And if you recall, if you think back to the last unit when we learned a lot about marginal revenue and marginal cost and businesses maximizing their profit, you may recall that marginal revenue tends to decrease as output quantity increases. And what you can see here is output quantity is increasing, and so therefore the marginal revenue is going to eventually be decreasing, and marginal revenue product is related to marginal revenue. Only marginal revenue product is related to the number of workers rather than the output quantity. But the truth of the matter is, here's the main reason that marginal revenue product is eventually going to decrease. It's because marginal product is decreasing. Remember that we're multiplying each one of these quantities by price to get the revenue. And therefore, as the marginal physical product decreases and we multiply by price, because our quantity is getting smaller and smaller and smaller in terms of marginal quantity, our marginal revenue product is going to get smaller and smaller and smaller. In the very same way, we can also explain it using the law of diminishing benefit, marginal benefit. And that is that the revenue that we earn per worker, so how much revenue is earned when we add a new worker, that's a benefit. Revenue is a benefit. And so as we keep adding more workers, the law of diminishing marginal benefit says that the benefit that we gain from adding another worker is going to become smaller and smaller and smaller and smaller. And the main benefit of adding more workers is getting more revenue. And so that benefit is going to get smaller and smaller and smaller and smaller. Okay? And so those are just a few questions that will help you understand why these numbers behave the way that they behave, and so you can better understand how economics is applied practically to factor markets and the use of factors in a business. All right, so now what I want to talk about is I want to talk about how a business can understand this information in terms of how it can accomplish its primary goal. And what did we say that the primary goal of a firm is in microeconomics? Remember that consumers, they want utility and they want to maximize their utility. Firms, they want profit and they want to maximize their profit. And so maximizing profit, we can actually look at this idea of what we call the profit maximizing number of factors of production. So let's say that a business asks, how many factors should I employ to maximize my profit? And remember, profit maximization is exactly what we're going for. We're not going for revenue maximization. We're going for profit maximization. Okay? Now, in order to understand this, here's what we need. Here's one of the things that I'm going to ask you a couple questions, and I want you to try and answer them to yourself as you're watching the video. In fact, you can pause the video to answer the questions. I want you to answer yourself, if the first worker is going to provide $391 in revenue, if adding one worker is going to provide $391 in revenue to the business, then what is the maximum amount of money that that business should be willing to pay that employee? So John walks up. They know that if they hire John, that John is going to earn them $391. How much should they be willing to pay John? Now, ideally, they're going to want to pay John less than the amount of money that he's providing for them, right? So obviously, ideally, we want it to be less than $391 so that the business can earn some profit on hiring John. But how much will they absolutely not pay John? Well, they definitely won't pay John more than $391, because if they pay John, let's say $400, and he only earns them $391, then they'll earn $391, they'll pay him $400, and they will be at negative $9. They're better off not even hiring John than being at negative $9. Okay, so we know that a business should never, under any circumstances, pay an employee more than the marginal revenue that that particular employee is going to earn them. Okay, but might they be willing to pay the employee exactly what it is that they're earning from that employee? Again, ideally, no. but they at least can afford to pay the employee $391. So if they hire John for $391 and he earns them $391, they didn't earn any profit, any economic profit, but at least they didn't lose any money. And so this is generally considered to be, the marginal revenue product is generally considered to be the limit on how much you're willing to pay for the next factor of production. Whether it's a worker or whether it's a truck or a robot, however much revenue the next factor of production is going to earn for you, that is the maximum amount of money that you are willing to pay for that factor of production, even though ideally you'll pay less than that. Okay? All right. So let's look here also at factor cost, or marginal factor cost. Marginal factor cost, isn't that pretty much what it is that you're going to be paying for that worker? If I add one more worker, I will increase my total cost by $300. Well, that means that that worker costs $300. So if we look at both of these together, marginal revenue product and marginal factor cost, here's what we see. If, when we add the first worker, our revenue will go up by $391 and our costs will go up by $300. Well, if we subtract this now, what we get is the marginal profit for the first worker is going to be $91. So we're actually making an extra $91. So if John comes along, let's just say, let's say Sarah comes along. We're going to hire Sarah. Sarah comes along, and Sarah can earn us $1,000, but she's going to cost us $900. Should we hire her? The answer is yes. She's going to earn us $1,000. We have to pay her $900. We get a free $100 just by hiring her. Now understand, that $900 that we paid her, it's not just her, that's all of the costs associated with hiring her. So if all of the costs are $900 and all of the revenues are $1,000, then we will profit by $100 by hiring Sarah. So we should do it. That's a yes. So here, if the marginal revenue product of the first worker is $391 and the marginal factor cost of the first worker is $300, that first worker is going to earn us $91. The second worker, their marginal revenue product is $409 and their marginal factor cost is $300. So if we subtract there, we get $109. So the second worker is worth $109 in profit to us. How about the third worker? The third worker has a marginal revenue product of $325 with a marginal factor cost of $300. $325 minus $300 is $25. So that third worker is worth $25 in profit to us. That's good. We're going to take it. But look what happens when we get down to the fourth worker here. The marginal revenue product of the fourth worker is $205, but the marginal factor cost for the fourth worker is $300. And if we subtract away the marginal factor cost, we get negative $95. And so what that means is that if we hire the fourth worker, we will actually lose $95 in profit. That's not okay. We're going to say no to the fourth worker. And so what we're going to do is, are we going to hire the first worker? Yes. Are we going to hire the second worker? Yes. Are we going to hire the third worker? Yes. Are we going to hire the fourth worker? No. And therefore, the profit maximizing quantity of factors, so how many factors should I employ to maximize my profit, is, in this particular case, is going to be 3 workers. Now, there's an easier way to do that than actually doing all this math. I want you to think back to the profit maximizing rule for production, for just quantity, for quantity produced, not for workers, but for quantity produced. And if you recall back, the profit maximizing quantity to be produced is the quantity where the marginal revenue of that quantity is equal to the marginal cost of that quantity. That if you equalize your marginal revenue and your marginal cost, whatever quantity is at that equals point, that balance point, that will be the profit maximizing quantity that your company should produce. Well, it's the same thing here with factors of production. We can basically just look for the place where marginal revenue product, which is basically marginal revenue, is equal to marginal factor cost, which is basically marginal cost of factors. Okay? So for factors of production, this is the marginal revenue and this is the marginal cost. And wherever they are equal, you will maximize the profit for your business. Now, in this particular case, there is no place where marginal revenue product is equal to marginal factor cost. So you're going to pick the one that's closest without marginal revenue product being smaller than marginal factor cost. And so that's this spot right here. You can see that this is the closest place where marginal revenue product is closest to marginal factor cost, and marginal factor cost has not gone over. And so 3 is the profit maximizing number of factors of production. All right, so now we're getting, here's, all right, so what I want to do is I want to wrap up this lesson with a transition into our next lesson. In the next lesson, we're going to show the supply and the demand curve for the factor markets. Well, we're going to focus mostly on labor markets, but we're going to show the supply and demand curve for factor markets. And so here's something I want you to understand. If we focus primarily on, or if we generally refer to factors of production, not just workers, and what I'm about to say is relevant to labor factors of, I really hate this. This is not working out. I need to walk away. All right, so I want to wrap up this lesson with a transition into our next lesson. In the next lesson, we're going to talk about the factor markets, supply and demand. We're going to talk about the determinants of supply in factor markets and the determinants of demand in factor markets. In particular, we're going to focus on the labor market. But what we're going to do in that lesson can be applied, most of it can be applied to any factor of production. Now, in this table, we focused primarily on workers or employees. But it does not just have to be workers or employees. Okay? It does not have to be labor. We could have capital here or we could have land here. But there's a hint in here. There's something in here that refers to the graphs of the factor markets. And that is the demand curve. And I want to show you how what we see in here reflects the demand curve. I want you to remember that demand is the willingness and ability, demand is the willingness and ability of buyers to buy a product. Well, now it's going to be the willingness and ability of buyers, of firms to buy factors of production. And so something in here indicates a business's willingness to buy and their ability to buy. And this is it right here. It's marginal revenue product. Okay? Remember what we said just a few minutes ago? We said that this basically sets the limit for whether the business is willing to buy, to hire a person. Well, it's the same thing for buying capital or buying natural resources. The business here, as depending on the quantity of the factor of production that they're going to buy or rent if it's labor, is limited by the marginal revenue product. So this first worker, or if it could be capital, this first factor of production, the limit on how much the business is willing to pay is 391. And the limit on how much they're willing to pay for the second one is 409. The limit on the third is 325, and the limit on the fourth is 205. And what you can see here is it starts off, it goes up one, but then it starts decreasing. You can see a negative relationship between the number of factors of production as it goes up and the marginal revenue product as it starts to go down. So we have this negative relationship. And because of that, the marginal revenue product represents the demand for that factor of production. Marginal revenue product tends to decrease as quantity tends to increase. So if a business is going to be willing to buy a large number of factors, they're only going to be willing to do it at a lower price because the marginal revenue product is going to be lower. But if the price is higher, they're only going to be willing to buy a smaller quantity. And so the relationship between price, what you're willing to pay, and quantity, when that's a negative relationship, we're talking about a demand curve. And so the demand curve in the labor market really is, this is the labor market, price and quantity. And remember, the price that a business is willing to pay is limited by the marginal revenue product. If the price of the first factor was $500, they would not buy it because they're only going to earn $391 in revenue. And so the relationship between the quantity of a factor of production that a business is willing to buy compared to its price is a downward sloping curve. It's a negative sloping curve, and that is the demand curve. Now, down here, the price is less than marginal revenue product. But up here, it's more than, it's greater than the marginal revenue product. In fact, the price is actually, if we understand this correctly, is the factor cost, right? That's how much you're actually paying. So if the price is the factor cost, so marginal factor cost, this is going to be a place where the marginal factor cost is less than the marginal revenue product, and over here is where the marginal factor cost is larger than the marginal revenue product. And so we can understand the marginal revenue product as the demand for this factor in the factor market. Now, one more thing you need to understand, though, is that this demand curve is not only represented by a single company. It's represented by all of the demanders for that particular factor of production. And so if we're dealing with labor, then this demand curve is represented by the marginal revenue product of all, sort of an amalgam of the, an amalgam is where you put a whole bunch of things together into one. If you think about aggregate, it's an aggregate, okay? So it's an aggregate of the marginal revenue product for all of the businesses that are going to demand this particular kind of labor in this particular labor market, okay? All right, so that's it for our introduction to factor markets. It's important for you to be able to calculate these three concepts. It's important for you to understand that marginal revenue product represents the demand curve in the labor market. And it's also important for you to understand that in a factor market, we still have a demand curve and a supply curve. So get ready for the next lesson, and in the next lesson we're going to discuss the determinants of labor supply and the determinants of labor demand, as well as a little bit of elasticity.